ask the jurors to introduce ourselves. And I'm Zhong Yuan from Chongqing University. And please.
Lian Zhenxun from National Central University.
Okay. Now, I think the opponent should raise your challenge to the reporter, isn't it? Oh, could the captain of each team introduce yourself and your teammate?
Hello everyone, your team Unlimited. I'm the leader of Chinese.
Hello, I'm Tang Shenyu from ISO from Asia International.
Hello, we are Team Miracle from Jianguo High School. I'm Wu Zhengwei, he's Liao Yuquan, Yang Yaoan, and Ye Zonghai.
Okay. Now, who's the first opponent? Opponent, please raise your challenge to the reporter.
And we have 1 minute to discuss.
Oh, okay.
The opponent challenges problem number 7, boson on screen.
Accept.
The reporter accepts the challenge of the problem of the ball and screen. Okay. Could the reporter list your name on the board, please? time is up. Reporter, please take forward.
Hello everyone, my name is Xu Chening, and today I'm going to report problem saver both on the street. And these are the outlines I'm going to talk about next. Introductions, problem statements, experiment, explain the phenomena, discussion, and conclusion. Introduction. Two wooden balls will be connected with a string. If we start to shake the string, the first ball will move like the outside of a double star motion, and the second ball will only move like the inside of the double star motion. Purpose statements. Put a string through a ball with a hole in it such that the ball can move freely along the string. Attach another ball to one end of the string where you move the free end periodically. You can observe complex movements of the two balls. Investigate the phenomenon. And as the problem statement say, this phenomenon is really complex, and I will try to use easy theories to get this explained. In my experiment, I drill holes on golf balls and pass string through it, and then I start to shake it, and I observe some question or appearance with my experiment. First, if I shake too fast, the distance between two balls will decrease. And if I shake too slow, the distance between two balls will increase. And at last, I can stabilize this system. And these two balls always collision while I'm shaking the string, and it may cause energy convert or like influence the velocity. And these two balls are not on the same plane, and it will cause like when I'm shaking it, and one ball will like maybe go right or yes, just it is not on the same plane, and it cannot just be stable at the same place. And these are the relative rotation we find out on the yes, and we can see the hand just move like at there, and but the outside ball did like out of double star motion, and inside ball didn't move really much at all. And because we found out some relative or principle involves of the swing, so we make some comparison between balls on the string and swing. First, we use handshake to give balls on the string energy, but when we are swinging, we usually move our body, like stretch our leg to influence swinging system. And we found out both of the key point is that we will force when the ball is at the lowest point, such as we stretch our feet when we are swinging at the lowest point. And we use our hands to give both of the swing energy to the wheel. But when we are swinging, we stretch our legs to change the centroid and potential difference. And I think that both we stretch our leg at the lowest point, or we shake our hand at the lowest point, or as the system tends to be natural frequency. And because this is not ideal circular motion, so the tension does work. Okay, so explain the phenomenon. Just force, we found out force when the ball is at the lowest point is a tip to control this system, and you can see it as natural frequency. Or and because we think at the lowest point can cause the best control of the system is because when you are closer to the lowest point and you are rising, it will cause more vertical displacement than when you are rising up to just when you are at the lowest point and you rise to this place, and at this place the kinetic energy is the biggest, so it will cause when you come from here to here, the vertical displacements drastic increase, but when you come from here to here, the vertical displacement just increase a little bit, and here is the relative between vertical displacement and the time. And I'm going to explain how we shake at the lowest place. It's because according to conservation of mechanical energy, when we are at the lowest point, vertical displacement drastic increase. So it will cause potential energy drastic increase too. And so then the kinetic energy will drastic decrease. So at that time, the kinetic energy will decrease lots. So if you work at that time and increase the kinetic energy, will be the best timing to work at that system. And so kinetic energy can increase as the best time. And this is another related to the system is radius of rotation. And when the radius of rotation is short, and we assume the omega is same, because the omega will definitely not be same, but we assume it's same, it will cause the force we need lower, and the work we done will be lower. And when the radius of rotation is longer, and we assume the omega same, and it will cause the force we do much more, and the work we do much more. And at this time we try to draw some like mark on the string, and we try to show it to tracker, but the tracker just give us because this is a CD, and as I say that these two balls are not on the same plane, and so tracker just give us 2D's data. So it will because they are not accepting stipulation for balls on the string, so it might be variables of experiment. And the experiment we do is like shake the string vertical, and if you use different materials of balls, like maybe plastic or wood, and it may cause different data. And if you use different ways to shaking, like horizontal or vertical, or even indefinite, omega will be a key point for this system. Conclusion. Just to remain a stable system, we found out that you have to control the amount of force, and force at the lowest point will be another key point. Because if we have a machine to control this system, and we let it force at the lowest point and let it use the correct force to this, and we might have a wonderful data. Conclusion: we found that there are 4 basic theory that gives this system the best explain its central force principle, and it depends on it decides on the radius of rotation. And the conservation of mechanical energy will be the key point that we talk about, force at the lowest point. And omega constant and Newton's law of motion will be like omega constant will be like things we cannot control, and the Newton's law of motion is just a theory of this, because maybe a gravity or potential will make it accelerate more or lower. And here are the experiment we've done. It's like when we are shaking this vertical and it will spin like this, but because it's not on the same plane, so it might like spin around or just like, yes, spin around. And here are another we do is horizontal, but we think that this is not the important, we won't focus on this horizontal shaking. Okay, thank you everyone. We will stop.
Okay. Now, does the opponent have any questions to the reporter?
Yes. Can you turn to a page where you explain your experiment in the very beginning? Yes, here. What do you mean by too fast or too slow? Is there a value of your speed?
Because
please give me a clear answer. Is there a specific value of your speed when you mean you are too fast or too slow?
now we can just control frequency.
Okay, thank you. Next, what do you mean by the two balls collide? How do they collide?
Just when we shake a string, the ball may like hit themselves, and it might cause the system cannot stable.
Okay. Next, do you analyze the forces by the string? Do you analyze the forces by the string? The magnitude and the direction? Yes or no?
No.
Okay. And next, can you please turn to the page where you show the graph of the trajectory? Yes, you can see that your hand has a both horizontal and vertical motion. Why is that? You say that it should be in only a vertical motion.
Yes, because when the system gets unstable, we'll try to make it stable again. So our hand might be just, our hand might not every.
Okay, why is the system being unstable?
Because like I say, this is not on the same plane, so it might like spin around or what.
Okay, thank you. My question is different.
The opponents have 3 minutes to prepare. take the floor.
Honorable juries and fellow competitors. I'm from Singapore and today I'm going to oppose problem number 7 proposed on screen. The problem states that if you move your hand periodically, you can observe complex movements of the two balls, investigate the phenomenon. The opponent gives an ideal structure of the investigation that differs from the reporter. First, we will construct the theory of the motion, and then explain the rotating motion, explain what is the criterion of the motion, and let's investigate relevant parameters. So here are the pros and cons for the reporter. So first, the reporter gives a good time management, but here are the cons. First, the reporter didn't give page index, making me hard to be focused on his report. Next, reporter has problematic experiment stating that it's a three-dimensional motion but using only one camera. And next, has a vague explanation to the experiment. Next, messy graph or no graph. The reporter gives first the messy graph on, you can see that, and he explained that there are many magnitudes or values when he gives no graph to prove. Next, the reporter didn't give a intuitive explanation, seeking that we can know how the balls swing. Next, the reporter doesn't give a unpersuasive theory because there's no proof from the theory and the experiment data. Next, the reporter has little parameter change. And next, there's a unnecessary comparison between the swing and the motion that the problem wants. And last, report knowledge to the phenomenon of the reporter. So today I'm going to discuss first the comparison of the two motions, then the verification of the theory, including conservation of energy and work. Next, and the qualitative explanation of the reporter. Next, force analyze and other forces such as friction, normal forces, and drag. Next, the motion of the ball. We will discuss the difference between hand forcing and stable oscillating force. Next, the significance of the middle ball being free, such is that what the problem wants. Next, the critical point to sustain the motion and the stabilization of the periodic motion. And here are the parameters. First, we will discuss the frequency and the amplitude of forcing. Next, then mass and materials. Then lastly, we will discuss the experiment that the reporter has conducted, two-dimensional or three. Next, and lastly, the data capture. And now I'm going to start our discussion with the reporter, please. So first of all, why do you compare the swing motion and the oscillating motion? Because in swing motion, there's no external force, whereas the oscillating motion, you get an external force. I don't see any meaning to compare the both motion.
Because like the swing motion is more like the pendulum motion, and this is like double star motion. But we think that also the key point is to force at the same time, or maybe.
So do you get a conclusion or a more clear acknowledgement on after comparing the two motion? If you can answer that, let's move on to the next question. Okay, next. You say that the energy is conservative, but how do you prove that since you constantly get force to the whole system, making that more work?
We didn't maybe like check it out, or because every time we shake it, we cannot check the outlet force, because if we use the like weight to if we use a weight to shake it, it cannot let it stable in a longer time.
Okay, so I believe that the conservation of energy doesn't work since that in every experiment and the same experiment you cannot clearly control the force you give, and the work is not always the same. So that gives the difference of the energy in every single period. Next, you said that you didn't analyze any forces on the system. So do you think that the friction or the normal force when the ball is rotating and the air drag do you think that these are important?
I think so.
So why didn't you do that? Why don't you investigate these parameters?
Because every time I shake it, it will have different like every time I shake it, it will have different experience data. So we can conclude that this is concluded, or can make a comparison with another one.
Okay. Next, you use a periodic force on your hand. Do you think that if you use a machine that can conduct a stable oscillating force, do you think that helps your experiment?
It may help a lot, because the question is we don't have that kind of machine.
But my opinion is that you say that your hand can manipulate every period so that makes the motion be stable. If you use a stable oscillating force, I think that the phenomenon cannot even happen. Next, okay, what do you think that is the significance of the middle ball being freeze, and how does it differ from the double pendulum, since the ball is not free in the double pendulum case?
Because these two balls have gravity between both them, and the radius of rotation.
No, my problem is that how do you think that the significance of the middle ball being free affects on the stabilization and how does it sustain the motion? Do you think that is a significant point to the problem? I believe that the ball in the middle can move freely because in every period the ball goes to a equilibrium that makes the motion sustained in a periodic motion, and for the case of the double pendulum, the ball can only stuck at a point, and causing only a pack of frequency and amplitude to the motion to make it stable. Do you agree with me?
Feel hard to be compared.
Yes, because the significance of the problem is that the problem say that the middle ball can move freely, and this is not very common because in most double pendulum cases the middle ball is fixed. So I believe that is a critical point that it makes the stabilization of the periodic motion. Do you agree with me? Okay, next. Parameters. You say that the radius of the motion can change. Can you explain it again? How does the radius change?
Oh yeah, this is the central force. Oh, sorry. This is the central force principle about if the radius of rotation is shorter, and because the omega thing will not be truly. Maybe it will be like almost, but
I'm sorry, what does the short and long mean? You mean that the radius or the period of your force?
the radius of
Okay.
rotation.
You said that the force is lower and the force is greater, but you said you didn't analyze any force. How do you know that the force is lower and other is greater?
Because this is, I think this is more like a theory behind this. Because the force cannot be, we didn't control it, and it's hard to be controlled, and so this is like a theory behind the phenomenon.
Okay, so can you explain why the radius changes when you change the force?
Because there's a we think the most of the system is when the radius change, we will change our force to let the radius of rotation just when it gets shorter, we will try to
Okay, that's
get
enough.
longer.
So you make the omega same, so you think that the frequency of the forcing does not change the radius. Is that true? True or false? Please, a short answer.
I think it's false.
So why do you control the omega same? I think you should make omega another parameter. So my opinion is that the frequency and the amplitude of forcing both will affect the motion, because if you consider the motion as a circular motion, you can see that the centripetal force F of C, Fc equals m 4 pi mr 4 pi squared over t squared. So if the frequency goes down, your period goes up. And if the forces are the same, the radius of the will also go up. So I think this is why the frequency will affect the radius of the problem. And next, do you change different masses of the two balls?
No?
Do you think that will affect the motion?
Yes.
And why did you change it as a parameter?
Because we did start try to change the material, and material mass is not same.
Do you calculate or measure the mass of the different materials?
Like almost every system will be like just like it's stable and unstable, and it just happen in short time.
Sure. So you did an experiment on different materials and masses, but you don't give any explanation or your experiment data on your report. Is that right?
Yes, yes, we cannot find some or like.
So you can't find anything to explain when you change the mass and material.
Yes, yes. Like every time, it's just happening in a short time, and it doesn't really like if you change your plastic and the radius of rotation will be like so long, and it will like when you are using wood or plastic, it will just like radius of rotation will just like as short as this.
Okay, that's enough. Next to your experiment, you said that you cannot control the system in a xy plane, but instead it is a three-dimensional motion. Is that right?
Yes.
Yes or no? So the way you capture your motion is only by one camera. If you use one camera to capture a three-dimensional motion, you only capture the projection on the camera where the plane is perpendicular to. So I believe that I suggest that you can use two cameras, one from the front and one from the side, to capture the whole motion. Or unless your experiment data will be completely wrong, since that it is only a projection, not a real data.
Yeah, like we have a lot of data with one camera between lots of degree, but like every time it's almost same. Like every time it seems like almost same, but we know that
It can still be the same when you use the same camera to capture the motion, because it is just a projection. But do you think that your data is accurate enough if you use only one camera? So you don't think that your data is accurate enough because you only use one camera instead of two cameras, right? Yes? Do you agree with me? Okay, yes. Thank you. My discussion is done.
Okay. So your phone will summarize discussion.
So first of all, we discussed why does the reporter compare the swing and the problem the motion that the problem wants. The reporter says that he only wants to see what is the difference, but he didn't give any conclusion about the results of comparing the two problems. And next, the conservation of energy reporter cannot defend his saying on the conservation of energy and the forces on the system. The reporter doesn't even calculate the forces on the system. Next, the motion. I asked the reporter what is the difference between using machine or hand. The reporter doesn't know. And next, limitable being free and the civilization, the reporter has poor knowledge on that. And the parameters and experiment, I can say that the parameters are investigated poorly and the experiment data are captured poorly, and that's our summary. Thank you.
Okay. Now, does the reviewer have any questions before voting?
I'm the reviewer from IS, and I have some question for you. Can you explain what exactly the double motion is? Double star motion.
Double star motion is like they have gravity between, and when one ball is inside, and another box outside, and the radius of rotation between will decide the like center side force.
And then how did you measure the speed of each ball?
We use camera to put it into a tracker, and we just see the data running.
Yes.
But actually, the speed will not change when we change a lot. So there's not really much data for us to put up. But because the speed is every time we shake it, the speed won't change. Just like from 1 meter a second to like 5 meters a second or what.
Yes, thank you. And I have a question for the opponent. Yes. You list out several possible parameters. Is there any other parameters that can be considered?
No, I believe that the parameters that I listed out are the most
Are the
important
most
parameters.
possible?
Yes.
Thank you. The graph, how do you design the graph? You didn't show any error bars. Do you think that is important to demonstrate to the audience?
Yes.
So about the chart, do you think it's negligible?
Yes.
Yes. This is the end of our presentation.
Okay. Oh, time's up. I'm sorry. Okay. Reviewer, please take the floor.
So we would like to reintroduce the problem statement. It says it's drawn strain of wooden ball, but instead of wooden ball, the reporter uses a ball, and the material of the ball is not accurate. And they didn't focus on the periodic motion, and they only said complex movements, which is very vague. And this is a reported summary. And then start with the observation and then move on to the theory, experiment, and discussion and results. And the summary of the opponent's speech, it gave out introduction about the problem statement, but there are some errors in it, and they list out the pros and cons, such as possible parameters and for other 2D camera. And for some few points, they list out some theories that can support their theory, and they analyze the motion ball. And they reported some specific questions, such as the frequency of the rotation and how do the ball exactly collide with each other. And they conclude a conclusion, and then contains the lack of theory, limitation of the experiments, and the data are captured poorly. And for the reporter, we found that they demonstrate their own thesis statement instead of following the question, and they had an adequate development knowledge in both kinetic and potential energy, and they had good time management, I believe that. And the cons, they did not use mathematical model and persuasive theory to support the question, and they only give qualitative data instead of quantitative data. And they neglect all the possible parameters, and the presentation is not detailed enough, and it did not highlight the main focuses of the problem statement. And for the pros and cons for the component, the pros are they have a clear and concise statement, and they address the question again with the reporter, and they observe and list out some possible parameters, which is very useful, and the reporter neglect everything. And for the cons, they did not came up with a theory relating to the parameters that you brought up, and you did not. It only mentioned the rotation of the motion of the rotation. Move on. And the discussion analysis component, you discuss the speed of the experiment and how they record the motion. You ask the results and the conclusion after comparison, instead of you compare it and then you conclude it. And for reported, you pendulum motion. You did not follow that very thoughtfully, and you did not discuss the effect of the radius, and you did not design an actual model for that, and you did not reconsider all the possible parameters. And the discussion analysis suggested for the report that you can use the machines to perform the experiment and use a more accurate view.
Time is up.
Thank you.
Yes. So the reporter, please conclude your presentation.
Okay, so I have some fault with I thought that gravity is not necessary or negative. This is my first is that gravity is not related to it, and because gravity will be like inside the Newton's law of motion. Well, like the gravity will work, and at this experiment we did like we use camera to focus on another degrees, but it's not the same time we shake the string, because this system we think that it can stabilize in a like short or maybe like 5 seconds. So we did try to put different degrees and like put it to the same, to put it to 2D to 3D. But yeah, but it's our fault to didn't try to use 2 camera or to focus on the same time experiment. Okay, the next one. Okay, so we still assist that keeping a stable have these tips, but yes, it's our fault not to try to put it into a 3D.
So, okay. Okay, time's up. So do the viewers have any questions for the host? Please? Yes, please.
Yeah, although you haven't yet completed it, but I mean for the following information. But what's your guess about the major difference between the characteristic behavior for vertical periodic motion versus in comparison with horizontal? What's the major difference? When you
I think the major difference is like maybe like gravity, because when the double star motion, like when it get down, the gravity does work. But at this time they are on the same vertical, and it didn't have the vertical displacement. So I think that it will be better to do the vertical.
okay, thank you. What's your guess?
So that the comparison between the swing and the yes. I believe that the horizontal motion that the problem wants stabilize the the motion, since that it gives constant work, and in every period the energy goes out and you give additional work to maintain the situation. But whereas the swing motion, it only swings and finally gets to a equilibrium point and it stops moving.
What's
And
your
I think that when it's in a horizontal motion, I think centripetal force plays a more important role in it. And when it comes to the vertical motion, I think gravity plays a much important role
in what way?
in up and downwards motion.
Okay, thank you.
Okay, I have a question for all of you. Please, use a few words to explain how did the central ball falls to the bottom physically. To the physical reason why the middle ball remains somehow where it is. Please.
The central force and the force friction will make it in the middle.
Okay. And
I think when it comes to vertical motion and due to the gravity, when it goes up and downwards, whenever in any direction, the middle point, when it turns to pivot point or fixed point, and so that remains the same position instead of moving, being unstable.
I believe that, and when the ball below goes down, we pull up the string. That makes the middle ball stays in the same position. And when the ball goes up, the two tension goes up, so that also makes the ball resist the gravitational force. But more importantly, the ball in the middle tends to go in the middle, stays in the same position, because that is an equilibrium point to stabilize the motion.
okay, thank you. So would you please calculate your final score? anybody report score? 5, 5, 5, 4, 4, and 4 for the reporter. Okay, now for the opponent. Nine, 8, 8, 8, 8, and 9. Pretty much consensus. All right, and then for the reviewer. 8, 7, 7, 6, 7, 7. Okay, thank you very much.
Sorry, Chairman, I have something to complain. I doubt that the reviewer uses internet in the entire competition, since we see that they use the Google PowerPoint on the competition.
The presentations are allowed during the presentation.
No, internet is not allowed.
Internet is not allowed in the whole competition.
Internet's not allowed in the competition, but we're using the offline Google Slack.
I think I've announced that no Wi-Fi, no network can be used during the competition.
We're using the offline shared Google. We're already downloading it. It's a Google.
But you're opening a Safari.
You are opening Safari.
Yeah, that's in her browser.
You're using an online sharing document.
Yes.
Yeah, we saw you sharing.
It's a
Yes.
Google site, but we haven't done any research.
I know you haven't done any
It's a
research,
Google site.
but you use shared document to edit the same.
We didn't edit it, we already done it before the presentation.
So you've already done the entire
The whole slide
It's an online it's an online
It's an online shared
Google
document.
site, but we didn't do any research regarding.
We already.
Yeah, it's not about
but
research,
but
it's
it's
about
still
you doing the same presentation at the same time. You're
Yeah.
using online shared document.
And you're saying that you're already done the
I think
review
the
after
judgment is on the
before the
jury.
discussion of me and the board.
So, okay, we'll record this argument and we'll report to the comments.
Okay, thank you, Chairman.
大家从外面抓资料进来，所以你们任何的资料需要从云端 download的，应该在开始之前把它全部 download 下来。那台上的人因为现在的科技的关系，如果有人在台下一边打字一边把资讯传给台上的人，让他秀出来，那这样子是允许的，因为他没有从外部抓资料进来。OK， 所以我们禁止的是从连网络到外面抓资料进来这件事。OK， 那只要有做到这种电脑跟电脑之间传资料、即时传资料这个的，你必须当有人有疑问的时候，你必须要能够说明你没有从外面抓资料这个事情。OK， 好吧？这样可以了。
所以我想大会刚才做了很清楚的说明，有问题吗？没有问题吧？
我们所以我们重新确认一个点，所以我们是可以用 Google Sites 去做的，因为我们没有跟外部的人做这个浏览记录就会证明这件事。那假如这样子的话，我们就可以继续用刚才的 Google Sites 来 present 这个，因为只有内部之间的。他刚才说，就算你即时电脑跟电脑之间的传送，只要你可以证明你没有跟外部取得资料，你就是可以的。所以理论上我们可以继续做我们刚才做的事情，因为没有违规的行为。
我还是把这个事情没问题。OK， 意思是这样 ，OK， 好，那这样讲好了，就是你只要你在这个过程中间，你没有从外部拿到资讯，是可以。好，那就是游戏规则定好了，让大家都可以照办。好了，那现在我想我们可以提前开始吧，是不是？大家都准备好了吗？
再一下下。
再一下下。
因为刚才都是下载档。 就是我们可以提早开始交，剩下的组愿意的话。
Is everybody ready? Okay. All right. Now, the opponent challenges reported. No problem.
Question number 2. Swing sound to you.
The reporter accepts the challenge.
Okay. Okay, reporter, please take the floor. And, all right, please start.
Good day all. I should begin reporting on problem number 3, swing amplitude. The problem statement goes as follows, which is if you swing a corrugated plastic tube in a certain, throw it around, it will make a certain sound. Which sounds
Keep your mask off if you don't mind.
which makes it makes this sound. So we want to ask, what causes this effect, and how is it affected by the throwing frequency, and what's for the sound? The sound has special frequencies and intensities. First, we want to look through the journal to see what literature can help us. Then, after determining the principle we want to use, we want to conduct experiments on how we can modify those principles so that we can better explain our theory, better explain the phenomenon. Then we will do experiments on our own parameters. Then we want to measure the sound intensity. So, the reference provides us with a very intuitive way of obtaining the effective speed of sound in a corrugated tube. So, if you can see here, the internal is defined as the area times the length, and the V total is the V internal plus the corrugated part. And through conservation of energy, we obtain the effective speed of sound as this. Now, when the tube is being thrown, of course, you can see that through centrifugal force, the air moves to the edge of the tube. Now, because the air velocity is low, the reference suggests that we can view it as an incompressible form, thus it has uniform velocity. Now, because of that, we can now utilize Bernoulli's principle with the assumption that it's frictionless. And it's frictionless, it can be compressed, so we obtain the speed of the air flowing through the tube as V equals omega L. Now we will validate this assessment later. Now, as to how the sound is being created, the theory is that when the high velocity airflow flows through the gaps, at the edge of the gap, it creates a self-excited resonant oscillation, which is linear, linear to the velocity of the airspeed. But from what we read it is much more frequently we observe that the black dot will be will resonate will lock in with the fundamental frequency of the tube, and will not show the linear dot that is shown here. So if it is too close to the fundamental frequency, it will lock into that. Also, for the fundamental frequency, it depends on the Reynolds number, and if the Reynolds number is too low, it will not show. We want to test the theory, but first, of course, we need to know the parameters of our tube, which is given here. Now, for the acoustic properties, we need to know the V internal and the V total. V internal is, of course, very easy to measure because we only need to do is multiply the area by the length. But for the V total, we fill the tube with water and measure the volume of water to get the volume. And when you blow the air into a tube, we can see that there are very clear peaks representing the fundamental frequency of the tube and its harmonic frequencies, as shown here. So it actually fits our data. This actually fits our theory that F should equal to 310, which is the speed over 2L. So the longer the tube, the lower is the fundamental frequency, which is 320. Now, for measuring the airflow rate, we tie the plastic bag to one end of the tube and throw the other end. Now, the theory is that V should equal to R omega, R being the rotating radius. We can see that if it is all according to theory, it should match this line, and because as you can see, our data is slightly to the deviates slightly to the right of the line, which we think this because of the friction and the overestimation of the rotating radius, being that this tiny area of the tube is being curved and will not rotate. So thoroughly, now as you can see, the fundamental frequencies are black blue lines, and in theory, they should the resulting frequency should match with the fundamental frequency and its harmonic frequencies. But as you can see, as the soaring frequency gets higher, the frequency does not exactly lock in with the harmonic frequencies. So we attempt to adjust our theory. Okay, so the tube was stationary when using the blowing through the tube. But when we throw, because the tube is stretchy, so the length will change because of the centrifugal force. But when trying to measure the F equal kx, we face some problems as the tube is stiff. So the area of this changing length is an area, not a value. But we came up with a solution that if we stretch out the tube before the experiment, so we pull it, then it will bounce back to a certain length, which is around 100 centimeters. Then we apply a force. Then we can get basically a perfect line of following Hooke's law. Thus we attain the K value. Thus we can attain the K value of the tube. So for tube stretching, as the method used in many this kind of problems is divided into many segments, many mass segments. So we view the cube as a combination of n sets of springs and masses, where n is the total n divided by the number of the cubes in the set. For simulation purpose, we use the drag being the beta equals to 0.05 and and the time period being 2 to the negative fourth power. And after we simulate Excel, we can get the length of the stretch when the tube is being rotated. So after we calibrate, we redid the graph before, and then we showed that so the fundamental frequency is this line. If the fundamental frequency after being adjusted is this line, then the predicted tube length can match with our theory much better. But again, of course, there is some error due to the friction and the overestimation of the rotating radius, because some of it doesn't rotate, but it inevitably will be calculated. And I'm sure you noticed, and in the phenomenon, you can see that there are peaks in intensity, so it goes. Now, so we analyzed the footage. We took a picture of a cell camera, and we can see that the peak in intensity occurs slightly just a few milliseconds after the free end of the tube faces our microphone. So it is pretty intuitive that when the free end points at the microphone, the sound energy will be sent directly, thus creating any higher amplitude and intensity. So, to conclude, why does this phenomenon occur? That is because when the swirling creates airflow as measured by the plastic bag, and when it floats above the bumps, the edge generates a oscillation, and thus excites alongside with the natural frequency of the tube, which is given here as n times c effective speed of sound over 2L. Now, how does it affect by the swirling frequency? Because the faster you swirl, of course, the length, as given in the model, the length will be larger. So the frequency of the swirling frequency will decrease along with increase of swirling frequency. So the sound, we measure the frequency and the intensity. So the frequency of the sound will be locked in with the resonance frequencies, fundamental frequencies of the tube, and the intensity will oscillate periodically along with the swirling of the tube. And that thus concludes my report. Thank you very much.
Any questions from the opponent to the board?
Yes, honorable judges, fellow debaters, this is Tanchino from Yichao International School, and we got some questions for you. First of all, in your experiments, how do you control the omega or the angular velocity? For all the experiments that you're not trying to set the angular velocity as independent or dependent variable. Like for when you're changing the length and the other, how do you control the spin?
I think you mean misunderstood because in this, I think you mean this.
Sorry. I mean any experiment you made. So
I mean yeah, like this tube. We used frequency, but we actually did not.
How do you perform the motion? How do you spin? Like
no. In this it is still. So we do not throw it. So
you put airflow in it.
Yeah. I blow on.
How do you control the airflow of the air that goes in?
In this experiment?
Yeah, when you're trying to keep all the air into the.
It doesn't matter. We only need to know the fundamental frequency because.
I mean, when you're conducting the experiment, how do you control these parameters that can affect your results? Or you didn't.
They are
control
not. They are not. It is not control because v should equal to.
So you believe
omega,
that changing the velocity of the wind will not influence the frequency?
Yes, of course it will because no, but
How do
it
you
is not
control?
control
How
because
do you measure it?
no, it is not control because.
Time is up. We plan on 3 minutes to prepare.
Honorable judges, fellow debaters, this is team ISOFs. This is our presentation for the opponent part. We'll try to restate the reporter's problem. So first of all, the question is, a sound tube is a toy consisting of corrugated plastic tube that you can spin around to produce sounds. Study the characteristics of the sound produced by such toys and how they are affected by the relative parameters. So we will try to recap the reporter's point. So first of all, they come up with a theory. They use the experience formula from the reference that they have put on the presentation. They also introduce Bernoulli's principle and resonant oscillation. And for a setup, they have various variables. Majority they discuss on the tube length, change in sound intensity, and also they use plastic bag, tube line. You use tracker to understand the change in sound quantity. They observe the acoustic properties of the tube. And for the data, they use like the swirling to create airflow, and the airflow will stretch the tube and result in a sound we hear. And then they put the data in graphs. And for the pros and cons we have come up for the reporter. First of all, they have reference to use the data. They have clear signs of property of their experiment setup. There are various detailed diagrams, and they have a very good theory background. And for the cons, what's the procedure of the experiment? We didn't see any setup, and like how do you guys actually perform the experiment? The photos or diagrams? What is the function of the attached plastic bag at the bottom? That wasn't elaborated clearly. What are the control variables of the experiment? That also wasn't shown clearly. So I have a few questions that I would like to discuss with the reporter. So first of all, as the question statement stated, the question is, you spin a sound tube. When your experiment, you use this airflow to put the airflow jet into the tube. But however, when you're swinging, it's a different phenomenon. There will be the angle of the airflow going into the tube will not be exactly the same. So have you tried to change the angle of the airflow and see how it will affect the frequency of the sound?
Yes, but funny you mentioned spin, because in your theory, it's quite clear that if you just spin it, you won't know, it won't create this phenomenon, because you don't know. In the theory, it is essential that one end of the tube is swirling, and the other end remains still, because then the end that remains still the air can flow into the end that remains still and then come out of the end that is moving.
Are you aware that you could easily construct the experiment using a Potter wheel and just attach the one end of the tube on the Potter wheel with a constant angular velocity, and you can create that, and you can change the angular velocity. Instead of in the observation you use your hand, and in the experiment you use this airflow into the tube. So, well, how do you explain all this?
Yes. So I think it's misunderstanding that the angular velocity should remain constant, but it is a very important variable in my.
Yeah, I mean, yeah, that was my question. I think that you didn't quite understand my question. My question wasn't how you control it. It's how do you measure it and control it to a constant angular velocity that you are intended to measure. For example, you have changed it to 10 radian per second. But if you're using that setup like that, then that is very inaccurate, and it's actually like more like a 3D motion, since it's not, your hand will like vibrate, and the tracker is only a 2D model, and there are also many other potential errors if you're trying to use your hand to produce the sound.
Oh, it's easy, because I can use a camera. Like I said, I use a slow motion camera, and then I see if the frequency angular frequency which it passes through the point.
Okay. Another minor issue, a concern we have for this method is that, have you ever considered Doppler effects, since the tracker is coming from this direction?
Yes. So glad you asked. Yes, so the Doppler effect should have occurred, but it is not easily analyzed. I'm sure you know the Doppler frequency, and because the period of swirling is too short, so that intensity peaks, because the microphone is here, so that intensity peaks here, and then there is no Doppler effect here, and then the peak measures this area where.
We would suggest this is a potential explanation, but we have some suggestion for you. First of all, you could easily solve this Doppler effect problem by placing the tracker on top of from looking at the top, then there won't be any relative velocity and won't have Doppler effects. And also, your solution is that you use tracker. but that you can see the graph is quite messy, and that each point wasn't the point wasn't distributed evenly. You just go over that page.
Why
I
is it
mean, like
important
most of the points are in the middle, while at the top and at the bottom there are only 2 or 3 points, meaning that probably the middle parts of the diagram are more accurate, while you only have collected 2 or 3 dots. So for 10 radian per second angular velocity, you only have 1 result. While in the middle, like 20, you have like probably 20 data. Do you think that the dots on the 10 radians per second might be an outlier that accidentally recorded? That you should, this basically most of the dots are around 20 radian per second on the x-axis. So my suggestion for you is that if you use the Potter's rule and attach it to it, and then you can use a tracker from the top view to track the angular velocity. That you can have a constant gap or constant intersection between each data on the x-axis instead of this clutter that mostly only measure the intersection between 18 radians per second to 25. You haven't done any, the data aren't sufficient after 30 radians per second. That was my suggestion for you. And also, did you also consider other variables other than these these variables you have discussed? How many variables have you conducted in your experiment?
So I changed the swirling angular velocity,
Yes,
the length of the rotating radius, and then
Okay. So have you ever tried to discuss the radius of the tube itself, or the gap between each corrugated line? How about longer corrugated line and the relationship to the frequency? How about larger tube, smaller tube? How does the radius influence that? And also the viscosity of the air, because this question is asking that you're doing it in the air. How does the temperature of the room and the viscosity of the air particles and all these possible parameters, have you controlled them in your experiments? Have you tried to discuss them in your or conduct experiments to see their relationship?
Yes. In our theory, because in our theory, the V internal is already factors in the area of the crossing area of the tube. So that includes the radius of the tube.
So how do you describe can you use a mathematical relationship to describe the radius of the tube and the inwards air speed, velocity? If you said there's a relationship. Okay.
No, there isn't. I mean, the effective speed of sound will be different.
My question is that there are external parameters that you haven't seemed to be discussing on, so such as the radius of the tube, and where are your discussion on these, or you haven't considered them in the experiment, or you just use the same radius?
Yes. The radius is included
in the suggest investigation in the future on how the changing the radius of the tube influence your results. And also we have other question regarding the how you collect the frequency. So have you ever considered that there might be background noises?
Yeah. So as you can see in this graph, yes. Look here. But so these are the peaks that we want. So
how about? But the question wasn't.
I don't know. The background can be something like this.
However, my question is that have you ever considered other sounds that might also produce not just because the primary source, which is the molecules collision, might there also be other factors such as resonance frequency? Have you ever tried to find the resonance frequency, which will be relatively lower than the frequency you observe? So
why? Wait. what resonance frequency are you talking about? You talking about
I haven't seen it in your presentation.
The fundamental frequency.
Do you think that the frequency of the air and the molecules produced might create resonant frequency?
Yeah, this is the whole point of this creating resonance frequency.
Yeah. So how do you?
So what resonance frequency are you talking about?
Basically, how do you control it and separate it from the background? Like, did you record the background noise first and then record the?
Yes, we have a blank. We have a blank file that shows.
So have you compensated the actual frequency of the after that?
No, we observe.
Use the software to edit it.
Yeah, we use the software to determine that's
another question I have for you. If you have already used software to do it, that's great. Is that you said that you use Bernoulli principle. However, do you know that there's a condition for Bernoulli principle that basically air shouldn't be turbulent, but when in the experiments the air flowing through is actually turbulent. So have you ever considered that your equation might be not as accurate?
Yes, so we use Bernoulli to acquire this V equal omega L, which we then adjusted. Yeah, the whole basically.
I mean that you shouldn't use the result to adjust your assumption. So first of all, your assumption of that this is a Bernoulli principle might have possible problems since that. It isn't.
I get what you mean. So the reference used by Bernoulli's basically you use a much more difficult principle, but I don't think
I didn't suggest any principle.
So the reference basically this is from V equals omega L is from the reference, and how also deducted it is.
Quickly sum up. So basically. For the reference, have you ever tried to conduct experiment to prove the reference equation?
Yes, the V equals omega L is proved in.
I mean
exactly
the
here.
original one, and also like the Bernoulli's principle. The assumption is not accurate.
Yeah. So we want to see if V equals omega L is correct. Thus, we use this experiment. If V equals omega R is correct, it will fit this line, but it didn't. So we adjusted.
That's a suggestion is that some of your data doesn't have a clear relationship. Like basically, some of them are actually ladder shaped, but you draw a straight line through it in some.
This is a series line.
In the other one, there's ladder.
Sorry guys, we're trying to stop. Okay, I'm going to summarize the discussion.
Oh, should I summarize? Wait, it's time to start? Okay, so basically, we summarize the discussion. Basically, the reporter tried their best to come up with a theory. They basically used a reference from former research, and that they have conducted sophisticated procedures. However, we believe that they should make the setup clearer. Some of the data presentation should be more accurate. For example, the data shape, they're trying to use a straight linear trend line. That wouldn't be so accurate. And also that the question is asking for a spinning tube. They should try their best to, instead of using tracker, they should use a constant angular velocity creation machine to create that. That's my summary. Thank you.
Thank you. Review 6
For the experiment that you pull the stretching, you stretch the tube. When you stretch the tube, you change the corrugated surface of the tube. And does this affect your experiment because the surface changes?
Yes, I imagine that will have some influence, but as you can see in the final calibrated results, it is quite small
Did
because.
you try to like minimize this error? Like does this affect your experiment, yes or no?
Not too much.
And like when you are like in all of your experiment, when you are spinning the tube, how do you try to make your speed at constant?
It is not constant. It is not constant. The angular velocity is not constant.
Like when you are spinning with your hand.
Yeah. I'm not sure what it is because it clearly is a constant. It ranges from 10
Like when if you are spinning at 10, like how does it release?
Oh, I see. So we use tracker to obtain the throw from each. We use tracker to obtain from each location. Obtain the.
And another question is, do you account the natural frequency in your experiment?
Yes, the natural frequency is given by the fundamental frequency. Of the tube, This is the fundamental frequency of the tube, and the harmonic frequency, and its harmonic frequencies.
Okay. I think that's it.
Thank you.
All right, time is up.
Hi everyone, my name is Chen Wei Chang, and today I'm going to be reviewing problem 3, swinging sound tube. So to go through the problem statement again, a sound tube is a toy consisting of a corrugated plastic tube that you can spin around to produce sounds, and study the characteristics of the sound produced by such toys and how they are affected by the relevant parameters. And first is the reporter. So in the experiment, they looked into various parameters like the stretch of the tube and also the sound intensity and it also investigated the acoustic properties of the sound tube. And the theory, they uses Bernoulli's principle, the effective speed of sound, and also the resonant oscillation. And for the pros, I think they provided some of the theories they provide are clear, and the formula fits several phenomena. And they constructed a clear and very complete data diagrams that also fits with the phenomena and their results. But for the cons, I think the setup of their experiment or their procedures, some of this is not clear. And for the Bernoulli's principle, because it should be under a steady flow circumstance, so it does not fit when the phenomenon is under a turbulence inside the tube. And for the opponent, I think they gave very clear questions, and they gave lots of suggestions to the reporter. And they also point out that the Bernoulli's principle is not right. And discussion for the first question. So when a reporter is spinning the sound tube, how to measure or allow the angular velocity to remain constant or stable? The reporter said he uses slow motion camera or tracker to check, and the suggestion is that maybe there are more better ways or better measurements to allow the angular velocity to remain constant. And for the second question, external parameters such as the radius and velocity of air is not discussed. So in the experiment, the parameters all remain constant, and we believe that maybe they can be in further experiment. Maybe these variables can be independent variables and should be tried. And for the third discussion, Bernoulli's principle can only be used under the condition of steady flow. So on the circumstance of swinging sound tube, because inside the tube is a condition of turbulence. So some of the data, so on the line or the diagram constructed, some of the data doesn't completely fits the line of the data performed by the theory. And that's it.
I shall remind
You have 2 minutes to prepare your.
I shall remind the opponents and the reviewer that the reason we use the reference is to show the equation B equals omega L, and the journal obtained this equation with a very complex, very complicated explanation. And what we use Bernoulli principle for is just a very intuitive explanation, and really doesn't have anything to do with the rest of our experiment. So now get out of the way. And I think that both the reviewer and the opponent wants to know about the angular velocity. And angular velocity, I can assure you that I use tracker to measure the angular velocity for for each and every rotation and each of every set of each rotation and each set of experiments. So I can show you that that's how we keep the angular velocity as shown in the graph. Lastly, I want to discuss again the Doppler effect, because of course the opponent eventually accepted my answer, but I should remind you that the Doppler effect is not significant at all, and that his suggestion that I should time the microphone to the end of the tube will significantly corrupt the data, either by blocking the airflow or even worse, significantly corrupt the data because of the wind blowing on the microphone. So yeah, that's all for our discussion. Thank you.
Okay. Do juries have any question for all the competitors? Questions?
I got a question for the reporter. You talk about the effective speed of the sound, right? And what about if there's no corrugation? What would be the value of this C effective?
I'm sure it will be very similar to the speed in open air. However, that is not
310 something like what you were saying. 310 meter per second, something like what you were.
Oh no, 310 is the effective speed of sound with the corrugation.
So with that, what do you think if there's no corrugation? It's
Yes,
going to produce sound. I mean, this tube is going to produce sound.
It reduced the speed of sound. Adding the corrugation bumps reduce the speed of sound. The effective speed of sound.
So no matter what, I mean, whether there's a correlation or not, it's going to produce sound, right?
The tube is going to produce its fundamental frequency. However, the fundamental frequency will be the amplitude of the sound will be very low, so that we cannot hear it. It's only after added the corrugation and that the oscillation resonates with the fundamental frequency and its harmonic frequency that you can hear the surrounding sound.
Have you verified that? Have you verified that when there's no corrugation and there was no sound?
No, there is not relevant.
Okay, that's fine.
Okay. Professor Lin.
So the opponent, you suggest quite a few parameters to investigate. Based on your own opinion, how those parameters will be relevant?
I believe that, for example, for the corrugated line, the density, if it is more dense, the frequency will goes up because there will be more constant turbulence and more turbulence will occur more frequently, and therefore the frequency will actually goes up. And for example, the angle, I believe that if you can use a steady flow to go in, then when the angle changes, when it's horizontal to it and just 180 degrees goes in, there will be the most airflow, and there will go straight through it instead of bouncing into it. So I believe that the frequency might also vary in the sine or cosine graph.
You also mentioned the diameter too.
Oh, I believe that when the diameter of the tube increases, the frequency will actually decrease.
Why is that?
I believe that since when the radius is larger and the pressure between the outside and the inside will not be as significant, and therefore the effect won't be as effective.
I will provide completely opposite answers to the two parameters. First, if you as given a theory, so increasing the diameter of the tube will lower the significance of the bump on the volume of the tube, thus making the speed of sound in the tube much closer to the speed of sound in open air, thus creating a higher frequency. However, if you increase the bumps of the tube, the area consisting of the tube, the bumps will increase, and thus decreasing the effective speed of the sound in the tube, and therefore decreasing the frequency you will hear. I think the opponent has it mixed up with amplitude and frequency.
Okay, I have a simple question for all of you. It seems to me that the airflow inside the tube is steady, right? Is your conclusion right? Is a steady flow inside the tube?
For the most part, yes.
Okay. Does it based on the assumption that the air is incompressible? It seems to me it's showing.
Yes.
Yeah. Okay. But obviously air is compressible.
Okay. Yes.
Is there any experimental method to verify that the airflow inside the tube is steady? Three of you. One word, yes.
Plastic one, I can see through it. Put the object in the measure the juice tracker to measure the blow.
Oh, okay, what about you?
I think it's downstairs.
It's not. Okay. And you? Any experimental method?
Okay, I can attach different types of plastic back to and see the rates and empties.
Okay, thank you very much. So the grading. Okay. Okay. Folder recorder. Okay. 7, 8, 8, 7, 7, and 5. And for the opponent, 8, 7, 7, 7, 7, 8. And the reviewer, 7, 6, 7, 8, 7, and 7. So the jurors are pretty much in consensus. And all right, let's conclude the second session of the class. 你们办联络大会，这边有同学身体不舒服。他现在人在哪？啊？他现在人在哪？
他现在人在厕所，
人在这里。那就让大会去处理。
对对对，
好，那我们开始。
就是通知。
好。那就开始我们这个。The opponent challenges the reporter for front.
The opponent wants to challenge problem 2.
Problem 2.
The reporter reject question number 2 inconspicuous.
Okay.
Will the amount of question increase because there will be less than 4?
Less than 4.
不能讲7月，对啊，所以其实才4个，要讲。
这同一场不能算同一个。
不能重复。
不能重复题。
对对，所以只剩4个，然后规则是说如果有4个开放，再开放题。所以
大家都比较
开放反复。
好像是开放，就是开放。
开放我们opponent board。
哦。
所以
是这样，像
所以现在可以报告的题目就是
会讲开他们opponent board 的题目，他们原本不能够讲他们opponent board，少一次的时候他们就可以讲。
所以现在可以报告的题目是3，然后5，还有9、13、15跟17。
Just like the stage. Just like the stage.
现在 opponent 要提出他们要那个
The opponent want to challenge problem 13.
First off, the reporter will accept this challenge.
大会有去处理那个同学吗？
有，刚刚有通知了。
有通知是吧？opponent 是陈宇。
我名字太熟。
这看起来是电影新天地。
我会检讨，我会检讨。不好意思。有点现实。
time is almost up. And the reporter please take the floor. And start your speech in 6 seconds. 4, 3, 2, 1. Alright, go ahead.
Honorable judges and fellow
Would you please take on your mask if you go on?
Honorable judges and fellow debaters, I'm from IRS Hawks team, and I'm reporting the problem number 13, friction oscillator. So the problem statement says that a measured object is placed onto 2 identical parallel horizontal cylinders, and the 2 cylinders each rotate with the same angular velocity but in opposite directions. Investigate how the motion of the object on the cylinder depends on the relevant parameter. So the important thing here is that the cylinder rotate in opposite directions, and have to investigate the motion of objectives based on the relevant parameters. So this is the table of contents. I will first show the observation, and then the theory, and then I did some 3 experiments based on different parameters, and then the discussion and conclusion. So this is the observation video that I did. You can see that the rod on the cylinder actually oscillate. So the theory. So their model, there is the use of Coulomb's law and Newton's second law. And so you can see that from the picture here, N1 plus N2 is equals to the mg of the rod, and then the 2 cylinders each rotate with the angular velocity of w, and then it creates a friction force that applies to the rod and make the rod move back and forth a part of the center and then back to the center. And then because I used the cylinders, like they rotate in inwards direction, so I apply the equation as F1 minus F2, and it's equals to mu k plus N1 minus N2. And then the mgx of the oscillator equals to 1 over 2 N1 minus N2. So combining the previous 2 equations, we can get the x dot is the differentiation with respect to time, and plus like the equation shown, and it is representing the rectangular motion of the solid. Therefore, it is a harmonic oscillator, and the period will be pi square root 2L over mu k and g. So I'll do some preliminary experiment to support the period of the oscillator. So there's some equipment. I use a vector tachometer to measure the rotation speed of the cylinder, and I use 3D printers to print 2 identical cylinders, and I applied 2 motors for the setup of the oscillator, and also use adapter power that can change the voltage, and then will change the velocity, the rotation velocity. And I use alligator clip and wire to connect all the motor and the adapter power together. So this is basically my setup. So I actually just turn up the adapter power and then use the tachometer to measure the rotation speed, and then I in order for me to control the variables of the rotation speed. So I have 3 parameters. One is increasing the length between the 2 parallel cylinders and whether it will affect the period of the oscillator. And the second one is different types of rod which influence the K value of the rod, and then see whether it actually affect the period. And number 3 is I want to do experiments that based on like the 2 cylinders rotate with different speed, and I want to see whether it's affect the period or not. So in order to quantify the value, I use I change one of the rotation speed of the cylinder, and then I increase the difference between the rotation speed, and to see this effect. So the first one is changing the distance between 2 cylinders. So the control variable is the cylinder diameter to cm, and control variables motor speed at 400 rpm, and also the weight of the rod is 20 grams. And I change the length, which is 6, 8, 10, 12, and 14 cm. And as you can see, the trend of the result is actually quadratic function, and it actually there's a positive correlation between the length of the cylinders and the period of the oscillator, which applied to the period to my equation of the period of the oscillator, and it is and the second experiment is changing the types of rod on the oscillator, and the types of materials I choose cast iron and PVC tube and glass tube and wood tube and steel tube. So actually control I also control the cylinder diameters and motor speed, and also the length between 2 cylinders is 10 cm, and that is the original length I did in the first demonstration experiment, and also the weight of the rod. So as we can see that as the K value of the rod increases, the period of the oscillator actually decreases, and it is also inverse correlation between both of them. So the third one is changing the motor speed of the left cylinder in order to create a condition that both cylinders are rotating in different speed. So I changed the rotation speed to 316, 3,800, 4,000, 4,200, and 4,040 RPM. So these are the pictures that I captured when measuring the rotation speed of the oscillator. So from the result, you can actually see that there is no relation between changing different rotation speed as we conduct the experiments, since the period of the oscillator actually remains stable, and therefore we can know that the rotation speed might not the different rotation speed might not directly influence the period of the oscillator. So this is the conclusion. So based on the equation, parameter 1 is increase in length, increase in, there's a positive correlation, and it is a quadratic function. And for the second one, it is different UK value, and it is inverse correlated, and then it is also a quadratic function. And parameter 3 is different range speed between two cylinders. So as the difference between two cylinders increase or even decrease, the oscillator period remain constant. So thank you. This is my presentation.
Okay.
So the first question is that you say it's a harmonic oscillator, right? So can I say that it's we will do a SHN? The motion is a SHN, simple harmonic motion.
Yes.
Okay. And you use mu k as the mu, and so it is the kinetic. So it's the kinetic function fiction, right? So I have a question that in the phenomenon you use the 2 mu. Oh, that's it.
That's the length of the rod.
Okay. Did you say that it will do a simple harmonic motion in the
When it's oscillating?
yes?
Yeah, at first, but I also observed that after like 10 seconds, you will actually vibrate very dramatically and eventually fell off the oscillator.
Okay. I didn't see how your tube or stick, the mass of the tube or stick. So the problem statement has said that the massive object. Do you think that the tube have enough massive, the mass to become the massive object, massive? The enough mass. Do the tube have enough mass, do you think?
Yes. Because I actually did an experiment, it works.
Thank you.
Oh, okay, time is up. The opponent, please take the floor and the reporter ready for discussion.
So, I'm the opponent of problem 13, and this is my outline. And let's go through the introduction. Problem statement. Friction oscillator, a massive object is placed onto two identical parallel horizontal cylinders. The two cylinders each rotate with the same angular velocity but the opposite direction. Investigate how the motion of the object on the cylinder depends on the relevant parameters. So, the highlight that I draw is the massive object and same angular velocity and opposite direction and with relevant parameters. So let's go through the pros and cons that the reporters. So for the pros, they explain the chart clearly and the theory that I think is clear, and it make people understand. But they didn't show many the setup and the data of the experiment, because I didn't see how they have the data of the motion, like maybe you will go down and forth like harmonic motion, the displacement vs the time, or some kind of the data that maybe came out of Shaker. So this is the pros and cons. And the theory they say about the comfort and Newton's second law. Okay. So they do the relevant, like the length and the radial and the mu and the radial speed. So next is my question. I want to. Okay, so you say that the motion is simple harmonic motion. So how do you prove that it's a simple harmonic motion? Do you have any proof for that? Because you know simple harmonic motion have a very specific kind of movement.
I think I derive the period from the simple harmonic motions, like the periodizations from the simple harmonic motions.
So you are saying that it's not a simple harmonic motion of your phenomenon.
It is.
So it is a simple, but how do you prove that? Because simple harmonic motion, you have to, you can, do you have any experiment?
You mean like data?
Yeah,
That's
data.
good. I did do the research to track the data, but I didn't put it on because I think my main focus between the period and the variables. But if you want to see the curve, I can show you.
Oh, okay, so you do the data. So did the data like a curve, a sine curve that all simple harmonic motion have?
Yes.
Okay. And the next question. So you say it's a kinetic friction. So how do you know that it's a kinetic friction?
Because there's a relative velocity when I put the rod on and the cylinder.
So I have another question for the friction. So the motors rotate inside, but why the friction go inside, not outside? Because we know that when we have friction, the friction will be on the opposite side of the force that we get. So why the friction go inside?
Like it is generating a friction force inside and then letting the rod to move.
So
Like
why the friction is not
the
outside?
friction may be on the
Because it's rotate inside, so the force it gives that should be the friction should be go outside. Why? Can you give like an example of some like experience or something?
like I did outward spinning and then the rod just fell off.
Oh. Okay. I think I have a better explanation about the friction that go inside. When you are walking, the force you go is forward, and the friction go forward. So you really is going force, but the friction go front. You know. Okay. So next, the messy object. So did you do the experience that you change the weight?
No, I didn't, but I mean I can do it in the future.
Okay. So do you think that how the mass increase or decrease will influence the motion?
I think it will influence emotion.
But based on your phenomena, you have no mass inside. The mass won't influence the T.
Then it won't. It may not affect, but it will increase the stability of the oscillator.
So if the mass is not enough, then what motion will it do? The same, or the motion will be if you don't change anything else but mass, then so the T will be the same, right?
The T won't be the same, but it can also apply to the motion.
But you said the phenomena didn't have M. The phenomena is without M, the mass. So you increase or decrease the mass won't influence the T, right? In the phenomena.
Yes, but if you have too little mass, and it won't actually have the phenomenon of the oscillator. Because the frictional force is too small.
Oh, the friction. So if I increase, so I make it's more heavier, then it will be the same motion that it did, right?
The same motion?
Yeah, the same T, the period, the same period.
So you're asking that if I change if my variable is the mass of the rod,
Yes.
the T will be constant. It
Yes.
still will be constant.
Because through your phenomena, you have no parameters about the M, the mass.
And then the mass will be a constant. The current will be a constant.
Oh, okay. So, the next question is that, can you go to the chart? The chart. Yeah. Here, I have a suggestion for the chart here that through the phenomena, the parameters and the norm have a root. It's the T equal root 2L, right? pi t2, yeah. So the charge should be here, should be root, 2t root here. Then we can, because you have the phenomena, then we can see that if it's a positive correlation or a direct proportional, direct proportion, yeah. So this is my suggestion for the chart. And you do the experiments that change the speed, right? So will the phenomena change when you change the speed? Because they rotate in different angle velocity, right?
Yes.
So the friction that so the friction is different, then will it still be a simple harmonic motion?
Yes, it will, because I did the experiment and it is the SHM motion.
Okay, so the result will be the same as you expected, right?
So I expect that it may have an influence on the period, but the experiment came out that it is actually all the same, with a little percentage error.
So you have the experience that you change the mu k in the second, yeah. So
How do I measure it?
yes, how do you measure the mu k?
So like I use I slide the tube down the flat surface, which the measure is the same as the 3D printers. So I can measure I use the tangent theta to measure the
I have another question about, so will the mu k be the same when you increase the angle velocity?
We found
Yeah.
we've done research on this. We found that there will be a not very significant correlation, but there will, and it will be quadratic at first, and logarithm at first, and then there will be a linear relationship. And as angular velocity increases, the mu k will have a decrease its value. However, we believe that it's not very significant, and we have to increase the RPM to very, very high, and still the mu k won't have a significant change. So it isn't shown clearly.
So you're saying that, but another question for this is, you didn't change the surface, but you increased the angle velocity. How would that be that not this one, the second? So how does mu k will change? Why does mu k change? Because you didn't increase. Maybe I.
Different material.
No.
I'm changing the mu k for another.
Maybe I won't start at this question. Okay. So, thank you.
Okay. The opponent summarize this question.
So the chart, they can put the parameters to root the parameters in order to make the chart more like the result, maybe like positive correlation or direct positive proportion. Yeah, positive proportion. Direct proportion. Yeah, direct proportion. So, and I suggest that they can do the motion of the displacement vs the time, the chart. then we can see that if through tracker we can see that if it's a harmonic motion or not. Then we can I think they did a good job on making the experiment. Yeah. Thank you.
Okay, so first I want to ask the reporter, why did you choose a cylinder rod? Like your rod looks like a cylinder. Why is that?
I choose it. Like, do you have any law?
Okay, so in your presentation, you said that after about 10 seconds it will become unstable, and do you think that that could be related to the shape of your rod? Because as the cylinder rod should be more unstable.
I think it will be related to the curvature of the rod and the cylinder.
Okay, thank you. Do you think that the weight of the rod might affect the rotation speed of the machine?
The weight?
The weight of the rod might affect the rotation speed of the machine.
No.
The reviewer believe that it will, and okay, so as the mass goes up, becomes larger, the rotation speed should be slower. So how did you measure the rotation speed?
By using the technology.
Okay. So what was your regression method in the first and second chart? Your regression method in the first and the second chart?
Excel.
No, like what kind of regression did you do? Is it linear or is it?
Okay.
Okay, thank you. And did you compare your theory to your experiment after doing so many experiments?
Yeah, I support.
Okay. And to the opponent, why do you think that the friction would be in the force in the opposite direction that the report mentioned?
I want to ask if to the common sense that every people had that
And do you, okay, so do you know that friction would be the opposite side of the relative motion of the two objects? So
Yes.
okay.
I just want to,
And to the reporter, are there any other forces that might work that might work on the whole machine? For example, air drag or other forces.
I think air drag might have a small effect on the oscillator, but like the amplitude of the oscillator actually is not very high.
Okay. Thank you. The reviewer is ready to report. Okay, hello, this is the reviewer from Team Miracle, and now I'm going to review the discuss on friction oscillators. So our focus on this statement should be like how friction acts on the object and how does angular velocity, how does the angular velocity change the motion. So this is the report. So the pro of the report was that they gave a very clear illustration. The con was that the focus was very unclear and there was no page index, and also they didn't really apply the theory to their experiment data. They only said, yes, they did apply, but they didn't show us any data or to prove that they did that stuff. And okay. As for the opponent, the presentation was about the pros and cons of the report. And the pro of the opponent was that he brought the setup of the experiment and the theory. And they also brought up how the chart was drawn, which is a very big problem. And also, however, they didn't give an outline of the discussion and they lacked knowledge of the theory. So the first discussion was that, was it simple harmonic motion? And the report says that the experiment proves it. The reviewer believes that if they did an experiment to prove it, they should put the graph on there. But another way of explaining simple harmonic motion would be to just look at the theory and it applies. And also, discussion on the kinetic friction as direction. And the report says that there is kinetic friction because there is a velocity. And the reviewer agrees with the report that it should be kinetic friction and the direction of the friction should be opposite side of the relative movement, which applies to what the report said. And the opponent also asked how the mass of the objects might affect this experiment. The report didn't make a clear reply. And the reverse believes that it should be related to the stability of this experiment. And also, because they used their machine to calculate the angular velocity, the weight should also affect the actual angular velocity and what is shown on their machine. And okay, so and also discussion on the angular velocity. And the report believes that it doesn't affect too much. And the reviewers thinks that the angular velocity should be related to the friction coefficient, and with larger angular velocity, the kinetic coefficient should be a bit smaller. And here are the points that they missed. First, the weight and the length of the object. That wasn't really one of their parameters. And also the radius of the cylinder, how that might affect the experiment. And also how friction was measured, because they only said that they measured it one time. However, the friction coefficient could be different on different positions. And also, when it actually has an angular velocity in the experiment, it might also change. And also, how the momentum and energy changes in this whole system. And another parameter that they could have done was where the position of the center of mass was. And how angular velocity affects friction, how the experiment applies to the theory, just like I said, they didn't show the graph. And precise calculation of the angular velocity, since the equipment should be affected by how heavy the object is. And also, what causes the instability after 10 seconds? And we believe that it should be the shape, because not only does the rod goes this way, it might also rotate this way. And the definition of massive, what is the boundary that can actually make this phenomenon work? And the also the air drag of the rod and how circular rod might affect the stability, just like I just said. And also the Grisham method. They only have a few data points, which they could possibly have used linear regression, but just because of the theory, they use a quadratic, which shouldn't really apply. Thank you.
So the reporter should go for your concluding remarks.
I would like first to reply to the reviewers about the shape of the rod, because I designed the cylinder as there's like edges at the outside of the cylinder, and that the rod is actually put on, and it's not actually stick on, but it is like I hope that the design can minimize the tilt of the rod, but actually like there's another factor is of the curvature of the rod and also the cylinder. So what is done successfully, the theory might be derived successfully in the experience with the theory, but like there's lots of improvements. like carefully set up of the experiments, and then some variables can be investigated in the future. And there's other relatively significant parameters such as the drag force and air drag force and how and what affects the cylinder to what affects the cylinder to tilt or fell off after 10 seconds. And I should also include page index and graphs of the checker result to show the essential information. Thank you.
Okay. Now, time for the George to raise the question. George, questions? Yeah, please.
Question for starting from the report. We know that amplitude is another key property of an simple harmonic motion. So, what do you think the parameter would determine the amplitude? Or maybe I ask in another way. Did you put the massive object in the center and then initiate the motion, or sometimes you put it sideways? Does the amplitude change at all?
I actually just did I first turned off the attack power, and then I control the cylinder to rotate the same speed, and then I put the rod just put it on.
Midway. On the middle
Yeah,
point,
and then
all the time.
yes.
Did you try start?
I did try just put it off first and then turn on the power, but it just it won't actually perform a constant motion.
Anyway, what do you think can you obtain different amplitude with different initial position?
Well, the amplitude will increase if you place a location or you drive.
What's your opinion?
I think that it won't change
It
because
won't change.
it won't change. Yeah.
What's your
The amplitude should only be determined by the initial conditions like position and also like the initial velocity that you push the rod.
Okay, thank you.
Okay, any other questions from the jury? No, I have a question for the reporter. You say that your experiments started becoming unstable after 10 seconds, right? So all your data are limited to the 10-second period. But the problem did not limit you to a period of 10 seconds. What happened after?
The rod started it oscillated dramatically and eventually fell off.
Yeah, but what caused it?
What caused it?
Yeah, do you
I think-
have any idea what happened? What makes it that the system becomes unstable after 10 seconds?
I think it might be the original setup. There's the curvature of the rod in the cylinder, and then the cylinders may not be exactly parallel, so it causes the.
Now, why in my opinion, you should do more observation after 10 seconds? Because this is also the motion of the system. All right, I have a question for the reviewer. You mentioned about the air drag. Do you think that's really significant?
The reason that I mentioned air drag was because by what the photos they showed, the rod looks like it has a hole in the middle. I'm not sure if that's the angle of the photo, but if it really is a rod with a hole in its middle, that should affect.
That's for one sample, right?
Yeah.
Okay. Any more? Okay, so let George, Brady. Okay. Alright, for the reporter, it's 7, 6, 6, 7, 7, and 6. And for the opponent, and 6, 4, 6, 6, 5, 6 is within experimental error. Alright, now for the reviewer. 7, 9, 9, 8, 7, and 8. Okay, before concluding the session, one theory, one physical law you mentioned is Coulomb's law of friction, not Columbus. Coulomb, which is like the electricity, Coulomb. Okay. But they might not be the same person. Probably not. Okay. Well, let's conclude this session. I'm happy to conclude this session. So many situations happen. This is a brand new experiment.